Hey guys, good night everybody. Just let me know if you guys can hear me properly before we start, please. All right, like I said, guys, I'll just let me know if you guys can hear me before we start, please. Okay, great. All right, so we're going to go through some questions on coordinate geometry tonight. So let's have a look at a question here, right? All of these are exam questions. So the diagram below represents a graph of a straight line which passes through the point P and Q. So we have 2 points here on this graph, P and Q. And the first thing we want to do, we want to calculate the gradient of the line segment PQ. Now, if you are given a question like this in the exam, actually, wait, sorry. The first part here, we want to state the coordinates of P and Q. So this first part here, this point P here, actually, could you all put for me what are the coordinates of P? Can you all put for me in the chat what are the coordinates of P? I will also need to know the coordinates of Q as well. Right, part A of the question, we want to know the coordinates of P and we want to know the coordinates of Q. For some reason, those kinds of coordinates tend to give students trouble. All right, they tend to give students trouble. I want to know what are the coordinates of P and what are the coordinates of Q. All right, I've seen some answers coming through. Okay, good. Okay, so let's have a P here. This point P here is actually 0, 3. Right, that's a point P. The point Q across here is actually -2 and 0. Those are the points there. All right, so that's the answer for part A. We want to know the coordinates of P and Q. The second part here, we want to work out what is the gradient of PQ. Now, typically what we need to do, we need to label our coordinates. Let's get a blank slide here. All right, so P was 0, 3. And Q was -2, 0. Now, the first part of the question, we want to work out the gradient of the line segment PQ. So the gradient of PQ, so there's a gradient formula, and that's given by y2 minus y1 all over x2 minus x1. That's our gradient formula. So before you even work out the gradient, my suggestion to you is to label your coordinates. So we're going to call this x1, y1. We're going to call this x2, y2. And then all we do, once we label, is just a matter of substituting into the formula. So my y2 here is 0. So this is going to be 0 minus 3 all over x2, which is -2 minus 0. So this is going to work out to -3. all over minus 2. So this is going to give us a gradient of 3 over 2. Okay. So that's relatively straightforward. So that's B part 1, that's the gradient of the line segment. The next part here, we want to determine the equation of the line segment PQ. So this is B part 1. This is part 2 here. Now, all straight lines follow a general formula, which is given by y is equal to mx plus c. Now, we just worked out the gradient of this straight line. We got 3 over 2. All right, that's the gradient of the line segment PQ. So therefore, m in this equation is 3 over 2. So this is 3 over 2x plus c. Now, c is considered our y-intercept. So there's no need to calculate anything. If we look at the graph here, our y-intercept here is actually 0, 3. So therefore, c is simply going to be equal to 3. So there are some exam questions where they just tell us to write down the equation. So the equation is going to be y is equal to 3 over 2x plus 3. So that's my answer for part 2. The next part here, they said the point minus 8t lies on the line segment, determine the value of t. So we have, so this is part C. So you know the equation of the line, y is equal to 3 over 2x plus 3. Now they are, plus 3. They are telling us that we have a point on this, on the line that is given by minus 8t. So this point here is given by minus 8t, and we need to figure out what t is. Now, if ever they give you a coordinate of a point on the line, what they are giving us here is this. X is equal to minus 8 and y is equal to t. So what we're going to do, we're going to use that information to figure out what is the value of t. All I need to do, I just need to substitute those two values into this equation here. So if y is t, it means that t is equal to 3 over 2 multiplied by minus 8, because that's x, plus 3. So 3 over 2 by minus 8, this will be minus 4, this will be minus 12, plus 3, and we're going to get minus 9. Okay, so let me know if that's making sense. Okay, so that is part C. What else do we need to work out? They're telling us that the line segment AB is perpendicular to PQ and passes through the point 62. Okay, so let's see where that line is here. So if this will be 5, this is 6. So the point 62 is going to be here. This point is 62 here. So what's happening here is that we have a line that is passing through the point 62, but it's perpendicular to PQ. So in this case here, this is what we have. We have a scenario like this. Right? I'm just drawing an estimated way of how this thing is going to look, right? So basically, we have a line, this line here. All right. Now this line here passes through this point here. This here is 6, 2. And we know that that line there, they're calling it line segment AB. So this is AB. And what's happening here, it's passing through 6, 2, but it is perpendicular to PQ. So that means that this angle here has to be 90 degrees. So we have to work out, they want us to determine the equation of the line AB in the form y is equal to mx plus c. Now, to do that, so the gradient of PQ, that was 3 over 2. That's the gradient of PQ. Yeah. So the gradient of AB Now, since AB is perpendicular, now the rules for perpendicular lines is if I take the gradient of one and I multiply by the gradient of the second one, we are going to get -1. All right, that's a geometric relationship between two perpendicular lines. So if you want to work out the gradient of AB, all I need to do is to invert the 3/2. So you invert it by writing it as 2/3, and we're going to put a minus sign in front of it. So therefore, the gradient of AB is -2/3. We also know that the line AB passes through the point 6,2. So it passes through the point 6,2. So here's what we know. So the equation of the straight line is going to be y is equal to mx plus c. That's for the line AB. The gradient is -2/3. So therefore, y is equal to -2/3 x plus c. But we need to figure out what c is. Since we know that the line passes through the point 6,2, it means that x here is equal to 6 and y is equal to 2. So we're going to substitute those two values to figure out what c is. So in this case here, when x is 6, y is equal to 2. So therefore, 2 is equal to -2/3 multiplied by 6 plus c. So 2 is equal to 3 into 6 is 2, so this is -4 plus c. So therefore, c is equal to 2 plus 4. So therefore, c is equal to 6. So that means that the equation of line AB is going to be y is equal to -2/3 x plus 6. Right? So again, some of you all are asking what paper are these from. These are from past CSEC questions. All right. I don't have the year written next to them, but they are all past CSEC questions. Okay. All right. So that is our first question here that we've completed. Let's try next one here. So we have P is a 0.24 and Q is a 0.610. We want to work out the gradient of PQ. So we have a point P, which is given by 2, 4. We have a point Q, and that's given by 6, 10. And we want to first work out the gradient of PQ. So in this case here, before we do anything, let's label. Let's call this x1, y1. Let's call this x2, y2. Always do that first. Okay. Next thing we're going to do now, we are going to work out the gradient. So this is part 1 here. So the gradient m is given by this formula, y2 minus y1 all over x2 minus x1. Okay. That's going to shift this. Let's bring this across here. Okay, so our y2 is going to be 10. So this is 10 minus 4 all over x2 minus x1, which is 6 minus 2. So 10 minus 4 will give us 6, and 6 minus 2 will give us 4. So that gives us a gradient of 3 over 2. Okay, so the first part here, you want to work out the gradient of PQ. So that's going to be 6 over 4, which is 3 over 2. So that's part 1. For part 2 now, we want to work out the midpoint of PQ. So there is a formula to work out midpoint. So midpoint of PQ is equal to, now midpoint, the answer is going to be a coordinate. To get a midpoint, what you're really doing, you're adding your 2x coordinates, x1 plus x2, and you're going to divide by 2. You're going to take your 2y coordinates, y1 plus y2, and you're going to divide by 2. Now this formula is not given to you in the exam, so you need to know it. So this is going to be 2 plus 6 divided by 2. Then we're going to have 4 plus 10 divided by 2. So again, you're going to get a coordinate. So 6 and 2 is 8. So that's 8 over 2, comma, 14 over 2. So in this case here, we're going to get 4, 7. Okay, so that's going to be the midpoint of PQ. So make sure you know your formula for gradient and make sure you know your formula for midpoint. Right, now this session has been recorded, so you guys can go back to the session if you need to. If you need to look at the question, just replay the video and you'll see the question. Okay, for those of you who haven't done so as yet, please remember to hit like and subscribe. You can also share this with your friends, right? That's not a problem. All right, so if you have anybody who's up at this point in time, just share the link for them and they will get access, so they learn something tonight. All right, what else we have here? So we have a line L and it's given by y is equal to 4x plus 5. We want to state the gradient of any line. We want the gradient of any line that is parallel to L. So for part 1 here, we have an equation of L which is given by y is equal to 4x plus 5. So remember, once you have an equation of the form y is equal to mx plus c, all right, that means that your gradient, right, m is equal to 4 in this case here. Now, when we speak about parallel lines, if I have a line here, I have a second line here, all right, and let's say I have a third line. If we know that the gradient of L, let's say this is L here, and your gradient is equal to 4, one of the geometrical rules for parallel lines is that they all have the same gradient. So in this case here, m has to be 4, m has to be 4. So it doesn't matter what line it is, once it is parallel to L, it will have the same gradient, right? So we're talking about the same 4 here. All lines parallel to L have a gradient of 4. Okay, so parallel lines have the same gradient. That's something we need to know. The second part here, determine the equation of the line parallel to L and it passes through the point 2 minus 6. Okay, so we're talking about an equation of a line parallel to L. So if it's parallel to L, we know that the gradient is 4. So therefore so this part 2. So that equation has to be y is equal to 4x plus c. Okay, we know what the gradient of that line is going to be. It's going to be 4. But we need to figure out what c is. So this is where the point 2 minus 6 comes into play. So for this here is an x coordinate and this is a y coordinate. So what that means is that when x is 2, y is equal to minus 6. Okay, so when x is 2, y is equal to minus 6. So we need to use that information to figure out what c is. So we're going to get minus 6 is equal to 4 multiplied by x, which is 2 plus c. So minus 6 is equal to 4 2s are 8 plus c. So therefore c is equal to minus 6 minus 8. So therefore c is equal to minus 14. Okay. So therefore the equation of this parallel line is going to be y is equal to 4x minus 14. Okay. Next question here. We have a straight line. It passes through the point minus 3, 5, and it has a gradient of 2/3. We want to write down the equation of the straight line in the form y is equal to mx plus c. Okay, so this is part 1. So we have a straight line and we know what the gradient is. So that means that m is 2/3. Okay, so that means that that straight line is going to be y is equal to 2/3 x plus c. Because remember, all straight lines have a general formula given by y equal mx plus c. And you know what m is in this case here? It's 2/3. So we're going to use the point P. And the point P is minus 3, 5. So again, just like with the previous question, this is an x coordinate, this is a y coordinate. So we know that when x is minus 3, y is equal to 5. So when x is minus 3, y is equal to 5. So we need to use this information to figure out c. So we're going to say 5 is equal to 2/3 multiplied by minus 3 plus c. So 5 is equal to 2/3 by minus 3 will give us minus 2 plus c. So therefore c is equal to 5 plus 2. So therefore c is equal to 7. So therefore the first part, they said equation. So the equation we're looking for here will be y is equal to 2/3 x plus 7. Okay, so that takes care of part 1. Part 2, they said show that this line is parallel to this line here. Now the only way you can show that two lines are parallel is if they have the same gradient. So we already know the gradient of the first line. Gradient of the first line is 2/3. So what we need to do, so this part 2, you need to start off with this equation here. 2x minus 3y is equal to 0. So we can say that 2x is equal to 3y. Or we can say that 3y is equal to 2x. So therefore, y is equal to 2 over 3x. So this here represents the equation of this line. Based on this equation here, this 2/3 here is your gradient. So all we need to do here is you're going to say since both lines have a gradient or have the same gradient, of 2/3, they are parallel. Okay, so that's how you're going to answer a question like that when it comes in the exam. Okay, let's see what else we have here. So in this question here, we have 2 points A and B that represents a line segment. The first thing we want to do, we want to determine the gradient of AB. So again, whenever you are given 2 points, you need to make sure and label them. So this is A. This here represents B. This is 3, 2. So step 1, before I do anything, I'm going to label them. So we're going to label this as x1, y1. Label this as x2, y2. All right, now part 1. We want to work out what is the gradient of AB. So gradient of AB. So we're going to use our gradient formula, which is y2 minus y1 all over x2 minus x1. So y2 in my case here is 2. So that's going to be 2 minus 4. And we're going to have that over 3 minus 1. So be careful with the negative signs for questions like these, right? So 2 minus 4 will give us minus 2. And 3 plus 1 will give us 4. So this is going to give us minus a half. Right? So that's going to be the gradient of the line AB. It's going to be minus a half. Part 2, we want the coordinates of the midpoint of AB. So this is part 2. So we just did a question with midpoint. So midpoint of AB is given by, so there's a midpoint formula, x1 plus x2 all over 2, y1 plus y2 all over 2. So in this case here, we're going to add up the two x values. So minus 1 plus 3 all over 2. We also have 4 plus 2 all over 2. So this here, minus 1 plus 3 is going to give us 2 over 2. 4 and 2 is 6 over 2. And therefore, this is going to give us a coordinate of 1, 3. Okay, so that's our midpoint. It's going to be 1, 3. So let me just ask a quick question here. Are you guys following with me here? I find the chat quiet tonight. Are you all following with me here? All right, cool. Okay, so that's part 2. This is the third part here. Now, I think in 2025, I think Jan 25, there are questions something like this. So they want you to work out the equation of the perpendicular bisector of AB. Now, you guys need to understand what is meant by a perpendicular bisector. Okay. So let's see. Now, I'm just going to draw a diagram here. I had a very simple diagram here to make sure we understand what is meant by a perpendicular bisector. So we have 2 points here. We have A and B. And what we know is that we worked out the midpoint just now. We just worked out the midpoints. Now, what a perpendicular bisector is, it's a line that is going to pass through the midpoint of AB, right? It's going to pass through the midpoint of AB, but it is going to cut at 90 degrees here. So this green line here is what we refer to as a perpendicular bisector. So it is a straight line that must pass through the midpoint of AB, which we worked out. We worked out the midpoint and we got 1, 3 here. All right. There are other things that we worked out as well. Technically, we know the gradient of AB. The gradient of AB here, that's this line. This M here is equal to minus a half. All right. Now, since the two lines are perpendicular, technically we know what the gradient of the perpendicular line is. Could you all write down in the chat for me what you all think the gradient of the perpendicular line is? What's the gradient of the perpendicular line for me? So I see students telling me the answer is 2. Yeah, I agree. All we need to do, you see this number here? Remember, the relationship between two perpendicular lines is that when I take the gradient of one of them and I multiply by the gradient of the second one, I should get negative 1. So if you know one gradient is minus a half, all we do, we invert and put a minus sign. When you invert a half, you're going to get 2. And if you put a minus sign in front of it, you're going to end up with just 2. So the gradient of the perpendicular bisector has to be 2. So we're going to work out what that equation is now. So this is what you know. So you know that the perpendicular bisector passes through the point, I think it's 1, 3. Yeah, 1, 3, right? So it passes through the point 1, 3. Okay, so this is an x value. This is a y value. Okay. We also know that this perpendicular bisector, so we're talking about the perpendicular bisector now. Right, so the perpendicular bisector has an equation given by y is equal to mx plus c. Now, you know the gradient of the perpendicular bisector, it is 2. So it's going to be 2x plus c. And what I'm going to do, I'm going to use this coordinate to figure out what c is. So we're just going to say when x is 1, y has to be equal to 3. So we're going to substitute that into that formula here. So this is going to be 3 is equal to 2 by 1 plus c. So therefore c is equal to 3 minus 2. So c has to be equal to 1. So therefore the equation has to be y is equal to 2x plus 1. Okay, so that's the equation of the perpendicular bisector. All right, I see some people asking about when will the topics, there are no topics. He actually doesn't release any topics for what's going to come in the exam. The only time they ever did that was during COVID, but they don't do that. They don't normally do that. We have to know the entire syllabus to be able to answer the exam, questions in the exam. All right, so that takes care of the third part here. All right, so moving on to our next question. So I have a line L and it passes through S and T. So we have S here. S is given by 6, 6. And we have T given by 0 minus 2. So the first thing we want to do, we want to work out the gradient of the line L. So again, x1, y1, x2, y2. We're going to use our gradient formula to work out the gradient of L. So this is part 1. So the gradient M is given by y2 minus y1 all over x2 minus x1. So we're going to substitute. So our y2 in this case is minus 2 minus 6 all over 0 minus 6. So minus 2 minus 6 will give us minus 8, and then 0 minus 6 will give us minus 6. So this could be reduced. So in this case here, it'll be 4 over 3. So the gradient of this line L here is going to be 4 over 3. So that's part 1. Part 2, they said they want the equation of L. Now, some students here, they might try to work out what C is. But if you read this question carefully, you see this point T here? That point T is 0 minus 2. So technically, you know what the y-intercept is. So the equation of this line L here, so the equation of the line. So look out for little things like that in the exam. The equation is simply going to be y is equal to 4 over 3x plus c. So in this case, it's going to be minus 2. So that's your equation of your line L. There's no need to calculate C. This here is already C. Okay? So that's part 2. The third part, we want to work out the midpoint of the line TS. So midpoint, so this is the third part here. So midpoint has a formula. So midpoint formula is simply x1 plus x2 over 2. y1 plus y2 all over 2. So you're going to add the two x coordinates. So that's going to be 6 plus 0 divided by 2. You're going to add the two y coordinates. So that's 6 plus minus 2 all over 2. So 6, this will be 6 over 2. And this one here will be 6 minus 2 is 4. So that's 4 over 2. So that's going to be 3, 2. Okay, so that's going to be my midpoint of that line there. Now the last part, part 4, we want the length of the line segment TS. So I haven't done one like this as yet. So there is a formula to work out the length of a line segment. Now that formula looks like this. If I have a straight line, a line segment here, and this is one point and this is a second point. So let's say this point here has coordinates x1, y1, and this one has coordinates x2, y2. Okay, now what I could do, I'm just showing you how we came up with the equation. If we try to complete a right angle triangle here, okay, it's a right angle triangle. This length here, from here to here, is actually going to be y2 minus y1. This length at the base here is actually x2 minus x1. So this length here is x2 minus x1. Now, I have a right angle triangle here, and you're attempting to work out this length here. So what we could do, we can use Pythagoras' theorem to work out the length of a line segment. So length has a formula, and it's basically Pythagoras' theorem we're using. So it is x2 minus x1 squared plus y2 minus y1 squared, and you're going to find your square root. Right? That's a formula that we're going to use. Again, you have to learn this formula off. Okay? So the length in this case here, the 2 points will, let me just copy this across here. All right, these are the 2 points here. So x2 minus x1, so that'll be 0 minus 6 squared plus minus 2 minus 6 squared. And we're going to find the square root of all of this. So this is going to be minus 6 squared plus minus 2 minus 6 will give us minus 8 squared. Square root. So minus 6 squared will give us 36 plus 8 8 is 64. Square root. So 36 plus 64 is going to give us 100. So therefore this is going to give us 10. And since we're working out a length here, we're going to put 10 units. All right. So that's how we work out the length of this thing here. Right. All right. So that's how we work out the length. So far we've looked at a formula to work out gradient. We've looked at a formula to work out midpoint, and we've looked at a formula to work out length. You need to remember again that parallel lines have the same gradient, and perpendicular lines, the product of their gradients is equal to -1. Okay. We have a next question here. On the section of your answer sheet provided, so they give us a piece of graph paper here. They want you to write down the coordinates of the point P. So look at where P is here. Want to write down the coordinates of that point P here. So P is simply going to be 4, 3. Right? So those are the coordinates of that point P there. It is 4, 3. So that's part 1. Part 2. Draw a line segment PQ through the point P such that the gradient of PQ is -3/2. Okay? So you want to get a gradient of -3/2. Now the first things first, this straight line PQ has a gradient of -3/2. Now the fact that it has a gradient of -3/2 means that the line has to be sloping this way. Okay, so I know the line is sloping this way, but because the gradient is -3/2, in terms of dimensions, right? In terms of dimensions here, this length here has to be 3 and this here has to be 2 based on how we calculate gradient. Okay, it's always, so gradient is really your change in y over your change in x. So if I were to draw a right angle triangle, it's always going to be y over x. So somehow the line that we're looking for has to be doing this, has to be sloping this way, but the slope of the line has to be -3/2. Okay, so let's just check something here. All right, so if you want to get -3/2, this is 2 here, we're going up 3. It means that this line that we're looking for here, right, has to go this way. right? This is the line that we're looking for here. This is the line PQ that we're talking about, all right? If I were to look at a straight line here, let's see. So I already know it has a negative slope, so I know exactly the graph has to be sloping this way. Also, when I look at the straight line here, let's try to complete a right angle triangle here. If I were to complete a right angle triangle here, all right, this is my right angle triangle here. This length here, from here to here, is actually 3 units. And this length here is going to be 2 units. Okay, so this is the line, that red line there is the line that we're looking for. Okay, so this question may be a little unusual for some people, but that's how we work out gradient. All right, I see some people asking about vectors and matrices. So guys, on my YouTube channel here, there are some very I'll do some more sessions, right? All right, so let's see. I have another question here. Let's see what's happening. All right, the diagram shows a line segment which passes through A and B. State the coordinates of A and of B. So for this one here, let's start with maybe B. This coordinate here will be 4, 6. And this coordinate A here will be -2 and 3. Okay, so again, I'm just going to write it on here because I can't see it properly there. This is -2 and 3. This B here is 4 and 6. All right, so those are the two coordinates A and B there. Now that's part 1. The second part, we're going to work out the gradient of the line segment AB. Now again, you can work out the gradient by using our gradient formula, just by labeling this as x1, y1, x2, y2. I'm going to work this problem 2 ways for you here. So our gradient, gradient is equal to y2 minus y1 all over x2 minus x1. So if we substitute here, it'll be 6 minus 3 all over 4 minus -2. So 6 minus 3 will give us 3. 4 minus -2 is the same as saying 4 plus 2. So that's 6. So this gradient here works out to be a half. All right, that's a gradient of the line segment AB. But I can do it the next way as well. Let's try to complete a right angle triangle using the points A and B. So if I were to do this, right, this is a right angle triangle here. Now, gradient, like I said, is actually your change in y over your change in x. So if I go to that right angle triangle here, all I need to know this length, or this length of the triangle here, which is actually 3 units. It's 3 units high, or 3 cm, because of the cm graph paper here. And on this axis here, that length here is actually 1, 2, 3, 4, 5, 6. So that's 3 over 6, which is a half. So you can actually work out the gradient just by looking at the graph, if you do have the graph. Okay, so that's your answer for part 2. It's going to be a half. And the third part, we want to work out the equation of the line that passes through AB here. So that equation is going to be y is equal to mx plus c. M in this case is a half, plus c. Now this c here, you can actually read it off from the graph. That c is actually 4. So there's no need to calculate anything here. So the y-intercept is c. So the equation is going to be y is equal to half x plus 4. All right. Yeah, I don't know why it was sticking there for a sec. Right? Could be internet on mine. Right? Could be internet on mine. Right? Again, all of these questions are CXC questions. Right? All of them. All right, so we want to determine the equation of the line which is parallel to y is equal to 2x plus 3 and passes through the point 47. All right, I won't do this one, right? I won't do this one here. I'll give you our next question here. Because there's something else that CXC tends to bring sometimes, right? Right, so this is something that CXC can access in the exam, and some students, they're not sure how to work out a problem like this. So let's start with part E here. So we have a straight line. It is given by 2y plus 3x is equal to 12. All right. So my question to you is, could you all tell me what the gradient of this line is? I'll give you a sec here. What is the gradient of this line? Write down for me in the chat, what's the gradient of that line there? Right? I just want to see some more answers. Some people say minus 3/2. I've seen 2/3. This is a common thing that CXC can bring in the exam, right? They can give you an equation and they can ask you for things like the gradient and the y-intercepts and the x-intercept. All right. Now, before you can state the gradient of any straight line, we have to write it in the form y equal mx plus c. A common mistake is that some students might tell me the answer is 3, but that's not true. I need to rearrange this equation first of all. So we have to say 2y is equal to minus 3x plus 12. All right. I'm trying to get it to look like this. The next thing that we're going to do, we're going to divide the entire equation by 2. So this will become y. This will become minus 3/2 x plus 6. All right. So based on that here, this here is my gradient. So the gradient is going to be minus 3/2. That's my gradient. Right. So this is going to be minus 3/2. So that's your answer for part E. What about part B? Let me give you a minute or two to work this out. What are the coordinates of the y-intercept? What are you all going to say for that one? What are the coordinates of the y-intercept? All right, I've seen some people saying 0.6. So let's check that. Yeah, so remember, this here will give you your y-intercept. All right, so once you have the equation in the form y equal mx plus c, all we're going to do, we're going to say the y-intercept is going to be 0, 6. I agree. What about part C though? What are the coordinates of the x-intercept? What are the coordinates of the x-intercept? Right, I see one or two answers there. So here's what you guys need to know when it comes to x-intercept and y-intercept. This is very important here when it comes to a graph. So on a graph, on a Cartesian plane here, this here is your x-axis and this here is your y-axis. Now, one of the key things you need to remember is that your y-axis, right? Let's have the x. The x-axis is also the line y is equal to 0. Okay, the equation of the x-axis is the line y is equal to 0. The equation of the y-axis is the line x is equal to 0. So sometimes you may be asked to find what is the y-intercept and what is the x-intercept. So if I have a straight line here, this point here, we already know that that's your y-intercept, right? And we already know that this here, this point here has to be called your x-intercept. Okay, so you could be asked to find the x-intercept or the y-intercept. CSEC can give us a graph and you look at the graph and you can work it out. Or in this case here, I just give you the equation. So I want to work out the coordinates of the x-intercept. Where is it cut in the x-axis? So all you need to do is say at the x-axis, what is supposed to happen at the x-axis? Y is equal to 0. So what we're going to do, we're going to substitute 0 as y into that equation here. So you're going to say 2 by 0 plus 3x is equal to 12, right? Because at the x-axis, y is equal to 0. So 2 by 0 is 0. So you're going to end up with 3x is equal to 12. And therefore, x is equal to 12 over 3. So therefore, x is equal to 4. So therefore, your x-intercept will have a coordinate given by 4, 0. Okay? So that's going to be the coordinates of the x-intercept. Right? So I saw a few people with that in the chat. Great. All right, great. All right, so again guys, right, remember to hit like and subscribe, right? Please share the YouTube channel. I've been doing this for about, this year makes it about 13 years I've been doing this for free. All right, so feel free to share to as much students as possible. All right, so I'm gonna pause here for now. All right, once I have more time, I will be doing some more sessions, so look out. I'll be doing sessions on CSEC maths. I'll be doing CSEC chemistry as well as CSEC physics. All right. So just subscribe and pay attention to the Facebook page as well as on TikTok. And I will let you guys know when I'll be going live again. All right. So guys, thanks for showing up. All right. Good night, everybody. Have a safe night. Good luck with your studying for CXC. All right. And hopefully I may have a session tomorrow. But I'll let you know. Right? Good night, everybody.